Alrighty, hey AP Chemists. This is going to be our next lecture, Important Information Part 2-5. We're going to talk about electrons in atoms now, basically getting ions, which are charged particles. So the number of electrons in a neutral atom is equal to the number of protons, typically. Another way to calculate electrons is protons minus minus the number of electrons is equal to the charge. Right? So if they were equal protons and electrons, if they were equal, protons minus electrons would equal 0. If they were not equal, meaning I'm probably changing the number of electrons, the charge is going to change from 0 to positive or negative. During chemical changes, atoms can gain or lose electrons and become charged particles called ions. Ions are charged particles. So for example, lithium has 3 protons and 3 electrons. However, it forms, it could lose an electron to form. I don't know why this says this. It loses 1 electron to form Li plus ions. So for example, I have lithium atom right here. This will have 3 protons, 3 electrons. Then I could lose an electron, and I'll have the Li plus 1 electron, meaning it lost an electron. This is kind of an ionization equation. Ionization is the loss of an electron energy required to lose an electron. So I'm kind of introducing that here. So if lithium loses an electron, it becomes the lithium ion. And you might be familiar with lithium ion. Lithium ion is what's in our batteries, like our phone batteries or any other type of charger. Okay? So that's after lithium loses 1 electron. If it lost 2, it would be Li2 plus. If it gained 3, it would be Li minus 3. We'll talk about that after, right? But I'll do another one. Like, what if I had chlorine? Chlorine can gain an electron, and it could become Cl minus 1. Again, now look at that here. This is Cl minus 1 because it gained an electron. So in that case, I have gain 1 electron. Okay? Ions can be positively charged or negatively charged. Positively charged or negatively charged. Positively charged ions are called cations, and the way that I remember that is because cations are positive. That's a nice little cheap way to remember that cations are positive, and then anions are negative. So anions are negatively charged particles. So examples of typical cations: Li plus 1, Ni plus, Ca2 plus. Sometimes hydrogen can form plus 1. Magnesium could do plus 2. Aluminum could do 3 plus. Strontium could do 2 plus, and so on and so forth. And then typical anions could be things like chlorine minus 1, fluorine minus 1, bromine minus 1, iodine minus 1. I could do oxygen minus 2, nitrogen minus 3, phosphorus or phosphide minus 3. All of these are different examples of cations and anions. If I look at any one of them, I could figure out how many electrons, protons, and neutrons it has based off of the symbol, right? So if I just quickly pluck out O2 minus right here, I have O2 minus. It looks like it gained 2 electrons from its protons. Well, I know it has 8 protons according to the periodic table. Its charge was minus 2. Charge is equal to protons plus the number of electrons. If I do the math here, electrons must be 10 electrons. And then if I knew its mass was, 16, that must mean that it also has 8 neutrons. Done. Because we know that mass minus protons is number of neutrons. Let's do a couple of examples here. Let's try to calculate all subatomic particles and atoms of elements here. So if I have nitrogen with a mass of 15, nitrogen, if I look on the periodic table, and I'll jump back for a couple of slides here. Nitrogen over here has an atomic number of 7, so I'm going to scroll all the way back. Nitrogen has an atomic number of 7, so it has 7 protons. It doesn't have a charge here, But over here it does, right? The element symbol is N3 minus. If I want to figure out number of electrons, it's charge is equal to protons plus electrons. In order for the charge to be -3 and protons to be 7, the only way this is possibly true is if the number of electrons was equal to 10. I have 10 electrons. Yes. And we could consider that electrons are negatively charged, so it's like 7 plus -10, right? So I'm going to go back up and kind of clarify that too. Let's assume that we know that protons are positive and electrons are negative. So I want to make sure that you know that when I do that, charge is equal to protons plus electrons, it's the positive protons minus the plus the negative electrons. Or it could be simplified. I actually did that over here. It's protons minus electrons. That's why I was doing the plus here. Whoops. I'll go back. It doesn't matter. You get the same idea. I'm going to redo that right now. So protons minus electrons. I kind of was saying the same thing. Plus minus is the same thing as plus minus. So I'll say this again here. If I want the number of electrons, we could say it's protons minus electrons is equal to charge. If I have 7 minus electrons equals 10, sorry, it's -3. Woo! Kind of mess it up here. Equals -3. The only way that this is possible is if the number of electrons is 10. I knew the answer was 10, and I was doing it a different way because I know that electrons are negatively charged. And so then the number of neutrons, well, if the mass is 15 and the number of protons is 7, mass is equal to protons plus neutrons. Well, if I know the protons are 7, what must the number of neutrons be in order to get 15? Must be 8. I must have 8 neutrons. Ooh, that was a tough one there. Let's do another one. I have something that has 12 protons. If I look on my periodic table with 12 protons, 12 protons is magnesium, right? I see that on the side there. So 12 protons is magnesium. Sorry for the scrolling. This is magnesium. Didn't get to the mass yet. Symbol is Mg. It's got 10 electrons. If it has 10 electrons, if I want to figure out the charge is going to be protons minus electrons. 12 minus 10. This is +2. Its charge is +2. It has 12 neutrons. Well, remember, mass is equal to protons plus neutrons. So 12 plus 12, that's 24. This has a mass of 24. Its atomic number is 12. This is magnesium 24. Done. So this is an example of trying to complete a table of figuring out all the subatomic particles and writing the element symbol. Don't forget what we've learned earlier about how to write the element symbol. Now we're including charge. Now I have bromine 80. Bromine, if I look on the periodic table, I'm going to just use mine on the side here. Bromine has an atomic number of 35, so it's got 35 protons. I did not tell you how many electrons it has. I didn't give you a symbol or charge, so I'm going to assume it's neutral. Assume neutral. I didn't tell you. I can't tell otherwise. The mass is 80. 80 minus 35 is 45. That's going to be the number of neutrons. Because protons plus neutrons equals mass. So mass minus protons is neutrons. And so I'll write the bromine symbol as Br 8035. Done. And there's no charge, so I'm not going to put a charge. All right, let's do the last one. Something that has an atomic number of 15. 15 is phosphorus. Number of electrons is 17. That means it's going to have a charge because it's not equal. Charge is protons minus electrons. 15 minus 17 equals 2 minus. 15 minus 17 is -2. So far I have P, 2 minus. It has 16 neutrons, 15 protons. 16 plus 15 equals 31 as a mass. Therefore, P, 2 minus with the mass of 31, atomic number 15, done. So, to summarize, protons are equal to the atomic number. We know that already on the periodic table. We have the number of neutrons is mass number minus number of protons. The number of electrons is going to be charge minus protons. Right? If I know the charge, I know the number of protons, I can rearrange that and figure that out. Or just remember that charge is protons minus electrons. Keep that in mind. Okay? And that's right here. Charge is protons minus electrons. Okay? Really, I'm going to reverse this one because we got the negatives and positive here. If I really want to figure out the number of electrons, it'll be protons minus the charge. And that'll make them positive. That's a better way of rearranging that equation. So it's a good little summary here for you. And we've talked about how to calculate protons, neutrons, and electrons in an atom. Again, remember the protons is the atomic number. That's the number on top in the periodic table. The neutrons is the mass number minus number of protons. Electrons is protons minus charge. Charge is protons minus electrons. There are elements that form some predictable charges, like elements in group 1 here. We'll talk about groups on the next one, but this is group 1. They typically form a +1 charge. Group 2 typically forms a +2. Transition metals we'll learn about in our next unit. They're wonky. Typically, elements in group 3 form a 3+ charge. 4 is skipped. Then we go the other direction. Group 5 is going to be -3 charge. Group 6 is going to be -2. And then group 7 is going to be -1. And so we'll learn about groups and periods, and we'll see that some elements typically form charges that are predictable. Alrighty, with that being said now, hopefully use this video. Sorry about a little bit of the mistalking. Like, I know what I'm doing. It just sometimes you just switch up the signs a little bit. With this helpful information here about summarizing, I'd like you to complete exercise 10 by filling, and 11 by filling in this table. Remember, just to make sure I fix what I misspoke, electrons are protons minus the charge. And then charge is protons minus electrons. So I'll do this like little last word in here. Osmium 6+. Osmium is on the periodic table. It's my favorite element. Osmium's atomic number is 76. So that means it has 76 protons. If I want to figure out how many electrons it has, I could do electrons is equal to protons minus charge. So 76 minus 7. Boom. Oops, not 6. Equal... Oh, yeah, 70, what am I doing? 76 minus 6. I was giving you the answer there. 76 minus 6 equals 70 electrons. And that would work out with getting the charge. I would be 76 protons minus 70 electrons equals +6. Boom. So if I wanted to figure out the number of electrons in the ion, it would be 70 electrons. Number of protons in the ion, 76 protons. And so the regular symbol would just be OS, osmium. Okay? Alrighty, so work on these exercises. Hopefully this was a nice little clarification. I was trying to go a little bit faster because it's just a quick little addition, subtraction math here. If you have any questions,